Hello and welcome to Designing Analysis Code That Scales. I want to go ahead and analyze some EEG data together so I can show you my workflow. And this is a workflow I find very effective when designing larger data analysis pipelines without everything growing out of control and turning into a Lovecraftian horror show. So let's dive right in and maybe you can learn a few new things. So this is some EEG data I prepared for us to use. This is the wonderful Brain Invaders project from these lovely people, and they're doing a P300 based BCI. So what that means is that we have 70 volunteers here, and these volunteers were looking at a screen with space invaders. And from time to time, a space invader lights up. Now you attend to one of these space invaders. And whenever your space invader lights up, you will get a nice P300 spike in your brain activity. So let's see if we can analyze this data and find the P300 peak. So here I've already populated a folder with a few files. So I started off with the study template that we also offer on our GitHub repository. And as you can see, I've already implemented 2 analysis steps. So in my workflow, each data analysis step is split off into its own Python script. So here I have the script that will download the data, and this script will pre-process the data, which in this case just applies a bandpass filter. See how I number these files, so we can easily see the order in which these files need to be executed. Now, this data analysis pipeline is at the point where we are ready to start cutting epochs. But before we dive in and write the third script, I want to show you the configuration file. This is the configuration file, and it's the heart of the data analysis pipeline. This is where all the important parameters are defined. And look, it starts with this little if statement here that will determine the system on which the data analysis pipeline is running. And so when my data analysis is running on my laptop, the EEG data can be found here. But when it's running on my workstation at work, the data will be here. If you are my collaborator, you can add your system to this list and where you've installed the data on your system and how many cores your system has. And in this way, we can use the same code and run it in different locations. It's great that we don't have to change it around all the time. Next, we have the all-important parameters. So normally, you would define your parameters in the data analysis scripts themselves. But there are 2 reasons for a parameter to end up in the central configuration file instead. And the first reason is that it is a parameter that is used in more than one script. So whenever you're writing code and at some point you realize, hey, I need a parameter that I've already defined in an earlier script, you take out the parameter and put it into the central configuration file. We never copy parameters. Each parameter should be defined only in one location. Now, the second reason why a parameter ends up in the central configuration file is if it's an important parameter that we should report in the methods section of the paper. By collecting all these parameters right here, when it's time to write the paper, I can go to the section of the config file and have a look at all the parameters that I need to describe in this section of the paper. And finally, we have the list of file names. In my data analysis pipeline, all file names are defined in a central location. And I'm using this nifty little file names class to help manage them. Let's see how that works. I run this script, and I have this fname object. And I can query this object to get different file names. For example, I added here the URL where the data can be found. And look, I defined a placeholder here, a placeholder called subject. So if I want the URL for the data, I can ask it, give me the URL for subject 1. There it is. Or subject 15. Bam, there we go. This is super useful to define your file names in a central location, because file names are used in multiple scripts. We will use file names all over the place, you will see it, and this strategy will make it so much easier to deal with them. Okay, let's not delay any longer. Let's go and write our third data analysis script, the script that will cut epochs. So let's call it epochs. Now, we start off with a comment. Always start off your analysis scripts by writing a quick comment. What is this script going to do? So we're going to cut epochs, and we're going to compute the evoke. Okay, we're going to be using MNE-Python. And from our central configuration script, we're going to need this fname utility class. Now, first things first, we need to load in the preprocessed data. So we're going to use MNE-Python to load this. Now we need, of course, the file name. So give me the file name of the filter data for subject, let's say 1. And go ahead and preload that. Is this running? This is running. There it is. Okay. We have the data? Yes. So next up is to find the events. Find the events in the filter data, and our stim channel is named target in this case. Okay, go ahead. Yes, we have 2 different types of events, and whenever a space invader was flashing that is not the space invader that we were focusing on, this is a non-target event, and that has an event code of 1. And whenever the space invader was flashing, and that is our target space invader, that's our target event. That's event code 2. Okay, let's cut epochs from -0.2 to 1 second after the stimulus onset. And let's use this negative time range for our baseline. So now we can start constructing epochs. So we need to filter data, the events, the event t, tmin, tmax, and our baseline. Let's see if that runs. Yeah. And now we have beautiful epochs. We have almost 1,200 epochs, lots of non-targets, a few targets. Wonderful. But hey, look at this. We have 3 parameters here that are the type of parameters that I need to discuss in the method section of my paper. So instead of defining them here, let's take them out and let's go to the configuration file. And let's define them here. So now I have all these parameters together that need to be mentioned in my method section. That's going to be very useful. Of course, now Python is going to complain that it cannot find the variables here anymore, so I have to import them right back into the script. Let's see. It's still running? Yes, it's still running. Wonderful. What's next? Computing evoke potentials. Okay, so we're going to have the evoked for our target. So give me all the epochs where my space invader was flashing and average them together. And also we have our non-targets, so give me all the other epochs and average those together. Running? Yeah. So let's see if we can visualize this. The target evoked and the non-target evoked. Go. Ah, beautiful. Look. This is the clear P300 effect. See, in the blue line, there's this peak. Whenever our space invader was flashing, we have this peak. And if it's not our space invader, we do not have this peak. This is the P300 oddball effect that we are looking for. So now, of course, we must save this wonderful groundbreaking result. So we're going to save this. And again, the file name class is going to help us out here. File name class, give us a file name for epochs for subject 1, please. You can overwrite this. In a similar fashion, we're going to write out our evokeds. Give me a file name for evoked. for our subject. And there we can write our target evoked and our non-target evoked. Right. Will this run? No, this will not run. No, it should not run because I haven't defined these file names yet. So let's go back to our configuration file and we're going to add two more files. We're going to have epochs and we're going to have evokeds. And the epochs are going to be named epoch and the evokeds are going to be named ave. These are standard MNE-Python template names that I'm using here. Okay, let's run it. And now it works. Great. So these are the evokes now for subject 1. But I want them for all my subjects. So one thing I could do is write a for loop. And put everything into a big for loop. But I'm not going to do that because when I do this, I lose the ability to run this script for a single subject. And I've been doing that all the time while I was developing this. This is very useful. As soon as I put in this for loop, I lose this ability. This is a terrible idea. I'm not going to do that. Instead, I'm going to bring in Python's argument parser. Argument parser, get over here. And we're going to define a new command line argument for this script. And this is going to be called subject, and its type is going to be an integer. And this is going to be the subject to process. It's going to be one of our 71 subjects. Okay, so now go ahead and parse my arguments. And let's store them into the args data structure. So now in args, we have a subject that we specified for the command line. And let's analyze that subject in our script. So now when I run this, it will start complaining. So I need a command line parameter. I need you to specify the subject as a command line parameter. So let's go ahead and do that. Let's analyze subject 2. That works. Let's analyze subject 37. All right, there it goes. Wonderful. I can now analyze any subject that I want, but I want to analyze them all. So now I'm going to bring in a build system. This is the PyDoit build system, and I absolutely love this. So what this allows me to do is to define tasks. And I define the task by writing a new function. So let's create a task for cutting epochs. Give it a short description, cut epochs and compute evoked. So now I'm going to define a subtask. For each subject, I'm going to define a subtask by yielding a dictionary. And this subtask is going to get a name. So let's call it sub and then the subject number in a nicely formatted manner. And I'm going to specify what files are required to complete this task of cutting epochs. Well, we need the filter data of the subject we're currently analyzing, and we're going to need that script we just wrote. Now I'm going to write down what new files are produced by this task, and this is our epochs and our evokeds. And finally, I'm going to write down which command needs to be executed to actually perform this task. And that command would be run Python on our script and to give it the subject as a command line parameter. Right, done. So now I can go to our doit tool and say, give me a list of all the tasks that I have defined. So I have here the download task and the pre-processing task, and now we have epochs task. So I can run this a task by just doing it like this, but I can also just run doit and it will perform all the tasks and all the subject tasks and everything. And it's going to be a bit clever about it. See, it already detected that all the data has already been downloaded, all the data has already been pre-processed, so all those steps are skipped. it immediately starts computing epochs, but it is quite slow. So I am going to cancel this. And there are 6 cores in this laptop. So instead, let's run 6 of them at. So this is running now 6 subjects in parallel. That's much faster. Look at it go. Okay, while it's doing that, let's finish up and write our final script, computing the grand average. Again, comment, compute the grand average evoked potential. Yeah. Again, I'm going to need MNE, and from our central config script, we are going to import fname, of course, but now also the subjects, because in this script, I am going to write a loop across all the subjects. And I'm gonna store everything into lists. So again, we have the evokes for the targets and from the non-targets. Let's name this plural. Now, for all the subjects, we're going to read in the evoked potentials. Give me the evokes for subject. And the condition, give me the evokes for the target condition. And also give me the evokes for the non-target condition. And let's add these to the proper lists of evokes. Now that we have all the evokes of all the subjects loaded, we can compute the grand average. So let's compute the grand average for the targets, average for across all the targets, and for the non-targets. Let's see, run. Python is. This seems to have worked. Can we plot this? Plot my target grand average and my non-target grand average, please. There it is. Look how clean that looks, averaged across 61 subjects. Very clear P300 effect. So there you go. Finally, one more thing to do, and that is to add this to the PyDoit system. So we have a new task to compute the grand average. Compute the grand average. And this doesn't need subtasks. This can just be a straight up task. So return a dictionary. And for this task, what files do we need? Well, we need the evokes for all the subjects, for subject in subjects. And we're going to need the grand average script that we just wrote. And what files does this produce? It doesn't produce any files yet because I forgot to save everything. So let's go back here and let's write the evokes, give me a name for the grand average evokes, and write the grand average evokes to this file. Now I need to go to the config file, and let's see, here we have files related to the grand averages, grand average evokes, and this is going to be not subject, but grand average. Okay, is this still running? Now it is. Okay, good. So now we can finish up these tasks. So we produce the grand average evokes file. And finally, we need to define the action. What needs to be done in order to execute this task? And that is to run this grand average script. Done. Okay, let's go back to our doit script. Do it. So all the epochs have already been computed. That skipped. It only needed to compute the grand average. And if I now would run do it, it will not have to do anything anymore. So there we have it. We have a wonderful data analysis pipeline. It's easy to see what all the steps are and in which order they are executed. We have a config file that's flexible enough that we can easily run this analysis in different systems, and you can easily configure this to work in your own system. We are using this PyDoit build system in order for us to be quickly able to execute the entire pipeline or parts of the pipeline in an intelligent way that we don't recompute things unnecessarily. And this is all I wanted to show you. I hope this was useful for you and you maybe learned some new tricks.